Hey guys, the objective of this video is an introduction to 3D settlement, and we're going to compare that to 1D settlement. We're going to be looking at the undrained and drained settlement. We're then going to be looking at how to find settlements at any time, and we're going to be looking at circular versus strip footing foundations. So this is just a very brief introduction for what's going on. Now in the past we've been finding 1D settlement, and we've been using the formula settlement equals minus the change in the void ratio times the layer thickness on 1 plus the initial void ratio. So that's the final settlement. And then we could find the settlement at any time using the graph, the U versus TV graph, the degree of settlement versus dimensionless time, where the U equaled ST on S infinity. So we could find the settlement at any time. And this was all for 1D. Now for 3D settlement, we're going to be using the parameters we developed in the previous video, the EU, the E dash, all that stuff, right? The most important thing for 3D settlement now is that if I were to draw a graph of what's going on, because we're looking in 3D, there's a big prevalence of this immediate settlement. So for example, our graph will look something like this, where this portion is the immediate settlement. So from here to here, this is immediate settlement. So let's just deal with this immediate settlement first. So the immediate settlement, so the immediate settlement, because this will be undrained, we're going to be using the parameters EU, E subscript U, so the undrained modulus elasticity, and VU, the undrained Poisson's ratio. And we're going to just call this S subscript I. So for immediate settlement, we're going to be using undrained conditions because the immediate settlement is undrained. Now, this up here represents the final settlement, S subscript F, the final total settlement. So for the final settlement, which is S subscript F, we're going to be using the E dash and V dash because this was for drained conditions. So I hope that makes sense. Because immediately it's undrained because the pore water pressures can't escape, the excess pore water pressures can't escape, and in the long-term future the sample will eventually become drained, which will be the final settlement where we use E dash and V dash, which was effective modulus elasticity and effective Poisson's ratio, compared to EU and VU for the immediate settlement. Now we're going to call this portion S subscript C, which is the consolidation settlement. And if we wanted to find the settlement at any time, so say we wanted to find this total settlement, we call that ST. We can see that ST, so this is from initial to final. If we want to find any value in between this, so any value between the immediate and final, this would be the consolidation settlement. Which we will call S at time t, so S at some time t. S at t will equal the initial settlement plus U S subscript C, where U is the degree of consolidation. So U equals degree of consolidation. So it's not the degree of settlement like we saw in the 1D case, that U, it's the degree of consolidation. So just quickly, the types of graphs we're going to be using. So if we wanted to find immediate and final settlement, the only thing that changes is EU and E dash, and VU and V dash. So if we look at the graph we're going to be using, it looks a bit like this. Don't worry so much about what it means now, but you can see it's dependent on V. So we use the same graph for immediate and final settlement. We just change the V values because VU and V dash will be different. For consolidation settlement, to find this settlement at any time, we're going to be using a graph like this. Okay, so at the end of the day, just realize that for immediate and final settlement, it's just undrained and drained values. So we use the same graph and just change the V because that's what this graph is dependent on. And for the consolidation settlement, the settlement at any time, we're going to be using this equation and a different graph. Now this process can happen over two types of foundations. It can either happen over a circular foundation, or it can happen over a strip footing. So a circular foundation is obviously a circle in plan. A strip footing looks like this. If we were in section, so here's our profile of soil, we would have a strip footing which goes on for infinity in length. There's a special way of dealing with this strip footing. It's sort of similar to the rectangle we saw for 1D, how we had to use the corners. It's a similar idea. We're going to be using edges, and you'll see how to do this when you watch the video. Anyway, this is just a brief introduction to what we're going to be doing in the next couple of videos. And yeah, guys, hope that helps.